All right, so here we have our first quadrilateral that we want to talk about, and it is parallelogram. So that comes from having two pairs of opposite parallel sides. That is the definition of a parallelogram. We have the opposite sides parallel to each other. There's a lot of properties that follow with that. You can see that from the markings on this picture. So actually for this, I'm going to draw just two pairs of parallel lines that are continuing forever to show where some of these properties actually come from. So really inside of there, I've formed a quadrilateral and I've formed actually a parallelogram. If these two lines, I'm assuming that those are parallel, I'm assuming that these two are parallel, already I know that this is a parallelogram. So some of the properties that follow, my opposite sides are congruent to each other. If these are maintaining the exact same distance from each other, they're parallel, and these are maintaining the exact same distance from each other, these have to be congruent to each other, and these are also congruent to each other. My opposite angles are congruent to each other also. So this angle and its opposite angle diagonally across, that angle is congruent. Same thing with this pair. That angle and that angle are congruent. And actually, we could just see this from our angle relationships. We know that these two are supplementary. Actually, that's going to be the next property. Consecutive angles are supplementary. These two are supplementary because they're consecutive interior angles. We have a pair of parallel lines and a transversal that crosses them. The two consecutive interior angles are supplementary. We have the exact same relationship here. These two are supplementary. So that means these have to be the same. They're supplementary to the exact same angle. And then really we could just do that round and around for all pairs of angles there. These two are also consecutive interior, so they have to be supplementary. So these two are supplementary to the same angle there, and they have to be congruent to each other. So really, all of this stuff, all this angle stuff is just our angle relationships that we know for parallel lines and a transversal. Then our diagonals bisect each other. That is the newest property that we kind of see there. Our diagonals are going from one corner to the opposite corner. So I'm just going to draw one of those and kind of just think about the implications of just that line. I'm not going to draw the second one. Really, diagonals implies that I'm drawing in both of them, but just for now, I'm just drawing that one. I want to notice what I have here. I have an angle here and an angle here that are equal, and I have sides that are equal to their opposite sides. So I have side, angle, side between these two triangles that I just formed. This one and this one are congruent triangles. We have a property that establishes that. So actually, I guess I could have also used side, side, side because that side is shared between them. So I just cleaned up my angle markings a little bit here. I just got rid of all the markings because I'm going to make new ones here. I'm going to mark this congruent to this angle. I know that these are congruent triangles, so corresponding parts of this one and this one have to be congruent. And same thing with this one and this one. Those are corresponding because they're opposite this side that I have marked with 2. These are corresponding because they're opposite the one I have marked with 1. I know that those are congruent too, but I'm about to split that angle up. I'm going to draw a second diagonal going from this corner to that corner. And now I have 4 triangles that are drawn there. And I've actually formed some more congruent angles. This, I'm thinking of that as the transversal for these two parallel lines. This one and this one. This is cutting across them, which means that this angle and that angle are congruent. Also means this one, I'm just going to mark this with 1 with a hash mark through it, 1 hash mark through it. Those two are also congruent. So actually what we just showed is that I have now 2 pairs of congruent triangles. This one and this one are congruent, and this one are congruent to each other. Okay, so I have pairs of congruent triangles, which means that actually corresponding parts again are congruent to each other. So this and this are congruent, and this is congruent to each other. So really all of that was just to get to these diagonals bisecting each other. Basically, this point is the midpoint for each of these lines cutting across our quadrilateral, which is all that's really marked there. Those two are congruent because they're split directly in half. These two are congruent because this purple line bisects the orange line. So these are the 4 properties that follow just from establishing these 2 pairs of parallel lines. And we'll see that since we've established it for parallelograms, everything that follows a parallelogram, everything that's downstream, everything that's under the umbrella of parallelograms, which is a rhombus, a rectangle, and a square, all of them carry these same properties. They all inherit these four properties directly from having that one property as a part of them.